Have you ever wondered what it feels like to make history? Imagine being part of a mission that not only achieves the incredible feat of landing on the moon, but also opens up a whole new frontier of exploration. That's exactly what India's Chandrayaan-3 moon mission has accomplished. By placing India as the fourth nation to successfully land a spacecraft on the moon and the first to land at its enigmatic South Pole, Chandrayaan-3 has set a new benchmark in space exploration. The mission's lander, Vikram, and rover, Pragyan, have already made groundbreaking discoveries about the moon's chemical composition and geological history. These findings are providing invaluable data for future missions and could profoundly impact our understanding of the moon. But here's the twist. What Chandrayaan-3 didn't find is even more intriguing. The Indian Space Research Organization, ISRO, India's equivalent of NASA, made it clear before the launch that their primary goal was to find one thing: water. Specifically, they aimed to discover water ice in the shadowy craters of the moon's south pole. The presence of water on the moon is a game changer. It not only supports human life, but can be broken down into hydrogen and oxygen for rocket fuel and breathable air. So, the big question is, where is all the water? To understand this mystery, we need to look back. India's Chandrayaan-1 mission in 2008 provided some of the clearest evidence of water ice in the moon's polar craters. This discovery was monumental because water on the moon had been hypothesized since the 1960s, but actual proof was hard to come by. In 1971, Apollo 14 found some traces of water vapor on the lunar surface, but water ice itself proved elusive. Scientists believed that if water ice existed, it would be in the craters at the north and south lunar poles, places that never receive direct sunlight and are some of the coldest spots in our solar system. But even with the promising water map confirmed by Chandrayaan-2, the actual detection of this ice remains elusive. Fast forward to Chandrayaan-3. Launched on July 14, 2023, the mission comprised a lander module called Vikram, a small rover named Pragyan, and an orbiter module that transported them across space. On August 23rd, Vikram, with Pragyan tucked inside, touched down on the moon's surface at the start of a lunar day. With only 14 Earth days to complete their objectives before the freezing lunar night set in, the clock was ticking. Despite the mission's relatively low cost of $75 million compared to NASA's $4.1 billion Artemis missions, Chandrayaan-3 was not designed to survive the lunar night. This made their mission timeline incredibly tight and crucial. Pragyan, equipped with an alpha particle X-ray spectrometer and a laser-induced breakdown spectroscopy instrument, set out to find water or other substances by analyzing the moon's surface. The rover found aluminum, calcium, iron, chromium, titanium, and excitingly, sulfur. The presence of sulfur hints at volcanic activity in the moon's past, providing insights into its evolution. But the crucial element of hydrogen, indicative of water, was missing. Guiding Pragyan was a delicate task. Scientists on Earth navigated it manually, carefully avoiding hazards. At one point, Pragyan narrowly avoided a 4-meter crater. Despite its slow pace of 1 centimeter per second, Pragyan managed to travel about 100 meters from Vikram. But, disappointingly, no evidence of water ice was found. Vikram wasn't idle either. It measured the moon's surface temperature and plasma content and even detected a possible moonquake. In a final feat, Vikram performed a 40 centimeters hop, testing the feasibility of future landers returning to orbit from the moon. So why didn't Chandrayaan-3 find any water ice? Vikram's temperature readings might provide a clue. It found that just below the moon's surface, temperatures dropped dramatically. At a depth of 8 centimeters, the temperature was minus 10 degrees Celsius, suggesting that lunar regolith is a poor heat conductor. This implies that any water ice is likely buried beneath the surface, protected from the sun's heat. This leads us to a tantalizing possibility. While the surface of the moon's polar craters may appear dry and barren, the ice could be hidden just a few centimeters below. This water might be ancient, possibly billions of years old, preserved in the moon's shadowed craters. It's not the ice lakes or frosty surface we might have imagined, but a hidden treasure waiting to be uncovered. Chandrayaan-3's mission was short, but its impact is lasting. It has offered valuable insights into the conditions at the moon's poles and hinted at where future missions might find water. It's clear that extracting this water will require a deeper understanding of the moon's water cycles and the ability to dig below the surface. Future missions might need more advanced technology capable of drilling deeper or melting the ice in place. As we continue to explore, Chandrayaan-3 has paved the way for future missions. Its legacy will inform the design and objectives of upcoming lunar explorers. The data collected will help us prepare for humanity's next giant leap, establishing a permanent presence on the moon. Imagine a future where astronauts dig below the lunar surface to find the water they need to survive and thrive, using it to grow food, create breathable air, and fuel their rockets. In the end, Chandrayaan-3 has done more than just explore the moon. It has deepened the mystery and excitement of lunar exploration. It has shown us that while the surface might not reveal all its secrets, the answers we seek could be just below, waiting for us to uncover them. So if future astronauts want to find a drink of water on the moon, they might want to start by bringing a shovel. And who knows, maybe one day it will be you or someone you know who makes that historic discovery. Stay curious and keep looking up. The moon still holds many secrets, and our journey to uncover them is just beginning. Don't forget to hit that like button, smash subscribe for more jaw-dropping space updates, and join us as we embark on a cosmic journey like never before.